All right, my friends. Nice to see you all. Yeah. Welcome back. I don't know about y'all, but these 5-day weekends are great. You should have them every week. Every week, I know. I did miss y'all. That's for sure.
I missed you as a basketball game yesterday.
I was there.
No, the rest of them. They're not loyal.
I was working.
Hey, who called out from the stands? Hey, there goes the soul man. That was awesome. I was like, yeah, baby, I'll take that.
He's so legendary. I'm like, yeah, you have to take his class. So next year he'll probably take you. He's an interesting character.
That's okay. I like interesting characters. All right. We're actually going to start on chapter 9, but tomorrow we will do a quiz. So this is my plan for today. I have a little bit planned with this and a little bit planned with that, and then we'll figure out the rest. Sound good?
Yes, sir.
All right. So I meant to tell y'all on Friday I was moving the test to last time I saw you. I meant to tell you I was moving the test, and I guess I forgot to tell you. Of course, it happened in my mind, I'm sure, but I don't remember.
I guess you might as well move the test to Monday now.
Okay, nope. All right, so there's no quiz today, which kind of probably takes anxiety off of some people, which is great. Yeah, I'll do it for you anytime, guys. We have our next unit that we're starting, and I'm going to do this plug, and then I'm going to show you a couple example problems that are to know for tomorrow how to do, and then we'll come back and do the rest of this lecture. But what I want to focus on is the second capstone test comes off this next unit. But I got a plan, and I created it, so I think it might be kind of good. I have something on Schoology that I'm just going to say, if you go and try it, I think I have allowed you 10 attempts. 10? And I'll take the highest score, but I won't put the score in until, like, end of March, because that's about how far away the capstone is. But it's a very user-similar to the types of questions that we'll be expected to do. Now, this is where I want you to take a little bit of pride. So yesterday, I had 8th period. No, I didn't teach them any extras, so they don't have any added advantage. I told them about this, and a lot of them just went and got a Chromebook and started working on it. And I had students that are mid to high C students as far as grades. They went through, and without learning any of the material that is on logarithms and exponentials, they were getting 50% on the Schoology portion without me even have taught anything. And so that's not my student that is the 98% in class. I'm talking about the student who's sitting at the 74 to 78%.
I have a 68.
Yeah, but you still owe me a quiz.
Mr. Sir,
So do you.
I know, that's what I'm saying.
Have you done it? I have.
What are the odds that you brought that test?
It brings up so much.
50-50. You're either well or wrong.
That's good.
I know you're not doing
Yeah.
You dropped the quiz last time, and I mean,
I know, it's because I felt sorry for you guys.
Mr.
That's rocky. I know.
I
wasn't so bad in that.
You'll do fine. So,
wait,
yeah, concussion boy over there still got to take it too, so he's not worried. He got a good old knock to it. Ben, you been here the whole time?
Yeah.
Dude, I'm sorry, I got to unmark you for being absent.
No worries. I just had some business to take care of.
Gotcha. Did you see the other bunch of our crew?
No, I had to watch.
Yeah, I've seen those too.
I
know Grant's here today.
All right. So with that known,
Sorry for being so mean today.
So with that known, I will just say this. On Schoology, there is, it's called log review or something like that. or capstone
No, it's log review.
log review? Sounds good. So this is like March 23rd or something like that. It's due. But I allow you to go through it 10 times. So then, the fortunate thing is if you go through it 10 times, and I don't expect people will, but I just wanted to put it out there because I'm sure if I put 9, someone would be like, dude, why don't you make it 10? So now I made it 10. Someone's going to say, why don't you make it 11? I'm going to say, get someone other teacher because I'm only doing it 10. I can do it up to 20 times, but I don't want to work that hard. And I don't think you either.
That's close to my birthday.
Your birthday's 20?
No, my birthday's 27.
Okay, expect cupcakes.
Well, Alden will be here. I think that's break time.
Well, I will show back up. If it's your birthday, I'll...
Wait, is it the 27th?
What?
Your birthday March? Oh, we'll be in school.
Nah, man. No break.
Yeah.
We're recording the
No,
Ben.
our break is the week before. It's not the last week.
I was going to say, Ben can't even figure out what day of the week it is. And he's like, month and a half out. No, we're here! I'm just giving you a hard
Definitely
time.
no.
Oh, you're...
We're here.
It's the 26th.
All right.
I've never
So-
been in school.
Hey, so does this make sense? So this is a homework assignment that's worth 10 points rather than 4. So you definitely want to make sure you do it. All right. Let's review a couple of graphing things. So just to let you know, you will indeed need the first questions on the quiz will be make the graph and show all of the things. That's a pi. So things I'm looking for on this, 1, -1, and then graph it. So that's question number 1. Honestly. So things I'm looking for. Did you label it correctly? And did you realize it was a sine curve versus a tangent curve? Okay. Then on this one, same thing. I got the +1, -1, and 0, pi halves, pi, 3 pi over 2, and 2 pi. And then cosine curve starts at a max, goes to a 0, goes to a min, goes to 0, back up. There's question number 2. I mean, seriously, I'm showing you exactly this. Again, do you know how to label it is important. And then the last one is tangent, and I'll make tangent more in the middle. Tangent fluctuates between pi halves and negative pi halves. And you have to know that, hey, I have an asymptote here and an asymptote here. And if I graph tangent at pi fourths, comma 1, okay, am I really looking for pi fourths, comma 1? No, not really. But the nice thing is this is the point that'll tell you if you have a vertical stretch or compression. But boom, you have that, and that's done. Giddy up. There's your first 3 questions. Yeah.
If the tan was negative, would it be going the other way then?
So if you had a negative in front of the tan, let's do this. If I had this be a negative here, it would look like that. Okay. Now let's change these a little bit. Let's do this. Let's do 2 cosine of x. So all that's going to do is take it up to 2 and down to -2, but it's still going to graph the same.
Nice.
Okay, and please make sure you have it labeled. Okay. Now here's kind of the key. Guys and girls, there's going to be graphs on the test that if you can't remember that it goes 0, pi halves, pi, 3 pi over 2, and 2 pi. Some of the later questions on the quiz actually have labeled axes. So if you're on page 1, you're like, I can't remember. You go to like page 3 and you're like, oh, that's right. But just realize that you have to know which axis is right because one of the axes might count by pi, 2 pi, 3 pi, 4 pi. So realize that's stretching. So that's cosine, right? And I just didn't label that. Well, how would I do, what happens here? What's the difference?
It stretches it, right?
It doesn't stretch it. It actually,
Oh,
so what's going to happen here is this is going to happen twice as often on the normal. So if this went from 0 to 2 pi,
So it shrinks.
okay, so it's a compression, so it's doing this. 1, 2. Okay? If I had this, cosine 1/2 x, this is going to do this. You only get half of it in your routine. Okay? So what technically should you do with these is, if I were to graph this, I would indeed graph it, realizing this is my parent function, and if this is 0, and this is pi halves, and this is pi, and this is 3 pi over 2, and this is 2 pi, if it's going to happen twice as often, change these. So multiply all these by 2. So 0 times 0, or 0 times 0, 0 times 2, pi over 2 times 2 is just pi, and then it's going to be 2 pi, 3 pi, 4 pi, and then that's 1 and -1 that you're labeled. Okay? Notice I have still these markings, yes? But then down below I'm clearly showing, well, if you read the scribble of stirrup, you can clearly see it's done. Yeah?
So when you're like making it move, like right on.
I haven't gotten there yet.
Okay.
Let's stick with these first. Everyone feel comfortable with that?
Yes.
All right. So let's go to what Salmon said. Y equals, let's do tangent x plus pi over 4. Okay. So not even knowing what this graph looks like. Am I shifting right, left, up, or down?
Left.
Left. Why is it left?
Because it's
Because it's positive grouped, right? So it's going to shift left. Okay, so I'm going to draw my normal tangent. I know tangent goes between pi halves and negative pi halves, and this of course is 0. Okay, so here's an asymptote. Here's an asymptote. This is what my normal. Bless you. That's what that looks like normally. Yes? So this means here, it shifts left pi over 4. So that means I'm going to subtract pi over 4 from everything. So negative pi halves minus pi over 4. Well, that's just going to be negative 2 pi over 4 minus pi over 4. So this is now going to be negative 5 pi over 4. Right? Wait, did I do that right? 2, no. Wait.
No.
Wait, I got a 4 there. Negative 3 pi over 4. Sorry about that. There we go. Okay? What does this become then? 0 becomes negative pi over 4. And then the same thing here. I'm going to go pi over 2 minus pi over 4. Common denominator, make that a 2, make that a 4. That's going to give me just pi over 4 right here. So notice, I can see that this is pi over 4. I can see this is negative pi over 4. I can see this is negative 3 pi over 2. Or actually, it should be over 4, excuse me. Okay, I just changed the labels. So is this green line right here still the y-axis? No, it's now pi fourths. Where's the y-axis? I don't know, right in here somewhere. Okay? How do I know it's in between? Well, went from pi over 4 to negative pi over 4, so halfway in between those is. So that's the long and the short of your graphing. Then you might have a problem that says this. Okay, sine, cosine, or tangent? Sine. It starts at the midline, right?
Yeah.
Okay. And I just didn't label. I got pi over 2 here. This is a normal traditional sine. Agreed? Other than it's being shifted up.
Yep.
Okay. So we want to know what the equation is. Okay. So y equals sine x, because it's a normal sine curve. We didn't go taller or shorter than normal, because this might, let's say this is 7, this is 8, and this is 6. Okay. So it goes up and down 1. What else do we need to add to this because our center line changed? Plus 7. Done.
Nice.
Okay? What if I had a problem like this? Found the Tempe twins.
So, how was your long weekend, sir?
It was good. I missed you.
I see it.
Okay. So just by what's bounded, what does it look like we're leading you to say this kind of curve this is?
Cosine.
Cosine. Everyone feel good with that?
Yep.
What if it started down here? Cosine as well? Okay, cool. I have a sneeze that wants to come out. Woohoo! Yeah, buddy. All right. So, it's a cosine curve. And it looks like it's just not expanding at all. But we're going to do something here. We're going to do something here. Does this appear that it's shifted to the right or to the left?
Left.
Shifted to the left. So if it shifted to the left, how much did it shift to the left?
Plus pi halves.
Pi halves, so plus pi halves. Done. What if I had my graph be this? Yeah, it's negative. So it's the exact same thing, but it's just... That's it, yeah. That's it. I mean, seriously. That right there is the majority of what's on the test. So there's going to be some questions where it's like, oh my gosh, I don't remember how to graph this. But it says, hey, what's the midline? Figure out the midline. That's pretty easy. Don't leave it blank. Try and figure it out. Okay? Yeah, Sammy.
How many word problems are we gonna have?
2. All right, 2 word problems. 2 word problems. Okay? You only have to do one of them. If you do both, you get extra credit. Okay?
What if you don't?
Huh?
You still get extra credit?
No, I'm not going to give you points for doing it wrong. Jeez. All right, 2 word problems. Very last problem. Okay, 2 word. One is the Ferris wheel. Okay, we've done enough of that. Okay, look back on Friday's video. I did one. And then there's one that has to do with the tides. Okay? And it'll say at 3 a.m. the tide is at 8 feet. And at 9 a.m. the tide is at 4 feet. And at noon, 12 noon, the tide is at, I don't know, 8 feet again or something like that. So, no, it's not a calculator one. So you have to kind of come up with it. So I think some of you that really know how to what you're doing on this, you can make it work. But again, there's 2 word problems. One of them is a tide. One of them is a One of them is the tide problem. And again, you only have to do one of the 2. If you do both, and you get them right, you get extra credit, which is kind of cool. Okay? All right. We good?
So
Is there anything that y'all owe me that I need to collect that I didn't collect? No. Don't give me the review. I'm not collecting the review. Does anyone owe me any old assignments that you have that I need to put in the book? If so, just put them in the orange folder.
all that's on the test tomorrow is like graphing and like identifying stuff.
No calculator unless you have 4 function. Plus, I didn't really teach you how to graph on the graphing calculator. These, so you should be fine. Cool? Everyone happy?
Nice.
All right, so if you have anything you need to turn in that might be late, orange folder it. If not, double check your grades. Your grades should be up to date. If I've made an error, which is always possible, let's right there. I noticed Kate sitting in back is a lot more quiet because when she sat up front, Kate wasn't on her phone non-stop.
And she wouldn't always react to everything people said.
You just got tired.
All right, so what do we have on Schoology that's due like March 20, whatever?
Nothing.
The capstone review.
Capstone review, baby.
Okay, we will do the capstone test when we get done with this unit. If any of you are like, dude, I want to take the capstone early, come see me. And again, I had students that played around with it yesterday. Students who are middle C students earn a 50% on the Schoology portion, which means that they should probably get a 5 out of 10, which you also need is a 7 on the capstone. All right.
Wait, so is it like the last one, or you can take it a lot and then like?
Yeah, but I don't really want to work that hard. I want you to pass it the first time.
Okay.
So that's why I'm trying to front load you doing stuff. You come in saying, hey, what'd you do on Schoology? I didn't do crap. You know what I'm going to say before I say, yeah, come in and review with me? Do the Schoology.
Will you double it like you did last time?
Yeah, it's still that. So it's going to be 7 questions, so out of 14. Whatever out of 14 you get is your test. If you get a 20 out of 14, you get some extra credit. All right.
Capstone you have to take?
There's one more after this one. We'll get at the end of the year. All right. You guys have seen this before? Would you rather have someone give you $1 million for a month's worth of work, or pay you a penny a day, doubling it every day?
Yeah.
And you come down to, once you do it, you realize, oh my gosh, there's so much money, and you think you're a genius because you're going to go tell somebody to hire you to make a penny a day, doubling it each day. And the thing about what this problem does is it's basically fourth day doubles 8. So this is what this graph does. So it takes off pretty quickly. Okay, and if our x-axis was being labeled as whatever day it was, the y-axis was labeled, that's how many pennies that they're offering us. Okay, so of course after the 4th day, you're like, dude, I made 8 whole cents. Yeah, I'm not going to do this anymore. But then you realize the next day it's 16 cents, 32 cents, 64 cents, $1.28, $2.56, $5.12, keeps going and going and going, and eventually at the 30th day, it's like $2.6 million that day you make, or something crazy.
Couldn't they just buy you after like 4 days?
Double a penny. It's 2 cents, 4 cents, 8 cents, 16 cents. Keeps going. So just think about how quickly it would go up. Okay, in the beginning it doesn't look like it's going up that quickly, but towards the end it's like, yeah, we're doing well. So it's just one of those critical thinking points to think about. All right, so we're going to talk about exponential functions. That's basically, hey, we're raising, our exponent is now going to be a variable. 2 raised to the x, 3 raised to the x, 4 raised to the x, 5 raised to the x. Okay? So things are going to grow very quickly. An asymptote is a line that we will approach, but we won't cross. There are horizontal, vertical, and slant asymptotes. They call slant asymptotes an end behavior asymptote, and it is related to the synthetic division, but we're not there yet. All right, so let's graph our regular parent function. So what would happen if I plug a negative in? So if I had 2 to the negative 1, it's going to be 1/2, right? So if I made our fun little t-table, now I went -2, -1, 0, 1, and 2. If I went 2 to the -2, that's 1 over 2 squared, and 1 over 2 squared is 1/4, and then I get 1/2, and then 2 raised to the 0 power, or a number raised to the 0 power other than 0, is 1. Okay, and then 2 to the first is 2. 2 to the second is 4. 2 to the third is 2 times 2 times 2, which is 8. So this is basically our parent function of an exponential function. Okay? Now, things that go along with exponential functions, we'll be talking about it more and more. exponential functions goes with something called compounding interest. Okay?
Like the bank stuff.
Huh?
Like banks and stuff.
Yes. Compound interest. I want you to hear this loud and clear. Compound interest, if you understand it, takes the average person and allows them to retire as a millionaire. Okay? Now, what's hard when you're sitting here at 15, 16, 17 years old is, dude, if I got money, I want to spend it now. I don't want to wait till I'm old. Gotcha. Compound interest is what allows the average person to retire as a millionaire. And if anyone says, oh, that doesn't work, I know. Okay? I will just tell you something. By the ways that I started investing when I was 18 years old, till now I'm 48, so we're talking 30 years. I'll just say, if you saw what my portfolio of my investments look like, you'd say, how in the hell are you a teacher? Okay? What was on my side? Time and compound interest. Okay? I'm telling you. And if I can do it, anyone can do it. And I will show you the method of it later, but I want to get through this lesson.
Sounds pretty interesting.
All right. Some on this last graph. Things that we have to realize. So this parent function has an asymptote. Of y equals 0. So this is my asymptote. It's not going to cross that. Okay? What do you think this one does? Shift up, down, right, or left? Yeah, it's not grouped, so it's got to shift up. So my asymptote on this one shifts up 3. And then my graph does the exact same thing, but shifted. Okay? What does this one do? Let's do orange. I already did orange. What do you think this one does? Shift up, down, right, or left?
Right.
So this technically should be in parentheses, so it shifts right. Okay? So my asymptote on this one is still here, because I'm just shifting right. So I'm going to take this and I'm going to shift it right. How many spots? 3. 1, 2, 3. Same exact function, shifted it right. Okay? So the asymptote, the exponent, if that is added or subtracted, it's going to tell you to shift it right or left. If it's added or subtracted where it's a low base, like the +3, that shifts it up or down. Can I move forward? Yay. All right. So my parent function, let me draw this first, is this. For the most part, that's my parent function. What do you feel this is going to do?
Move it down to? I mean, just flip it over the Y.
Flip it over the X or the Y.
Y.
So let's think about this. If I still do my table, -2, -1, 0, 1, and 2, still with me?
Yeah.
So this negative right here is an afterthought with the 2. It's not being influenced by the exponent at all. So 2 to the -2 is 1 over 2 squared, which is 1/4. So this gives me -1/4. So -2, -1/4. If I plug the 1 in, 2 to the -1 is 1 over 2. And the negative of that, -1/2. 0, 2 to the 0 is 1. And the opposite of that, -1. So if I have a negative on my base, it flips it over the x-axis, or whatever my horizontal asymptote would be?
How does that work though? Because you can't have like negative days.
Don't look at it as days. Don't stop putting labels on stuff that don't have labels.
Okay.
Think of it this way. That right there is as I go to positive infinity, the red line goes to negative infinity. Okay? So it's an exponential growth still towards the negative direction.
Okay.
Okay? All right. Let's think about this one. Does this have one shift or two shifts? Two. What's one of the shifts?
Move.
Up one and right three. So which one am I going to look at, the blue or the red? Well, the blue is my parent function. So I'm going to look right here. I'm going to use this as my go-to point. So I'm going to go up one, still with me? Yeah. And right three. Bless you. Okay. My asymptote moved up one because it shifted up one. So now we're going to get okay. Did it shift up? Yes. Did it shift right? Yes. Okay. Find that one point that's a critical point to know. Usually it's where it crosses the x-axis or the y-axis on your parent function, and make that your shift point. May I move forward? Yay. All right. Parent function, again, is this. Here's my asymptote. Here's my fun point. All right. What do you think this is going to do? Do what? Yeah, it's a vertical stretch of 3. So it's still going to have the same asymptote. Here's my asymptote still. Okay? But this point is not here. It's triple that. So think about this. If I plug 0 in, I get 2 to the 0, which is 1. 3 times 1, which is 3. So it grew faster. This one, it's going to flip over the x-axis or x-axis, okay, and grow at the same rate, but it's going to grow at a half as fast. So let's plug 0 in. 2 to the 0 is 1. Negative 0.5 times 1 is negative 0.5. So that's like here. Okay? So this one is going to get fat. So it's going to do this. So look like it's not growing as rapidly. Try to make it look like it's a little fatter.
Just like me.
You're husky. I'm kidding. Parent function. Dude, it changed to 3 to the x. Are you serious? Yeah. 3 to the x. Okay, plug 0 in. 3 to the 0. It's here. Plug 1 in. Doesn't this look like my last parent function? The only difference between that and y equals 2 to the x.
It's kind of like graphic parabola, but there's only one side wire.
So, doubles the height, left 2, flips over x-axis, grows slower, so fatter, if that's politically correct. I'm sure there's some group out there that's offended that I said fatter. How do you think the line feels? You called it fat. It's an inanimate object. It doesn't know any better.
You're just lying, Mr. Stone.
All right. All exponential functions in the form y equals a times b raised to the x have a point at 0, comma a. If I plug 0 in, I get b raised to the 0. b to the 0 is 1. 1 times a is a. All exponential functions in the form y equals a times b raised to the x will have an asymptote at y equals 0.
What's that?
It's a horizontal asymptote. It's a line that I won't cross. Okay? All exponential functions in the form y equals a times b raised to the x will have a domain. Ooh. A domain of negative infinity to positive infinity. So if you plug negative numbers in as exponents, you flip over your number so you get a really small fraction that approaches whatever your asymptote is. And the range,
0 to positive infinity.
yeah, 0 to positive infinity. If I had a negative on the a, this would be 0 to negative infinity. And I need to change one thing.
Wouldn't it be
That is a rounded bracket. The reason it's a rounded bracket is 0 is an asymptote. I approach it, I don't cross it, and I don't touch it.
nice?
You know what an asymptote is? Any of you have brothers or sisters or cousins that irritated you in the back seat of the car?
Yeah.
Mom, Tommy's touching me. And what's Tommy doing? Not touching you, not touching you, not touching you. You became the asymptote. Okay? Because Tommy technically wasn't touching you, but you're like, dude, seriously. Okay? My cousin Lisa, oh, I haven't seen Lisa since probably 83 or 84. It's been a long time. But she and I were like a month apart, and I still remember this day. I mean, I had like these little snippets in life that I remember. Lisa liked to bite. And it wasn't like this like little thing. It was like the death, Rottweiler on steroids bite. I'm sure on the back of my tricep since 1973 there's still a scar of Lisa's bite mark. But we sitting there in the back of the car, wow! And I look over and Lisa would go, that's my cousin. She liked to bite.
Pay attention.
I know that she liked to bite.
She was. Yeah.
How's she doing now?
She passed away.
Oh.
Because she bit something. I'm kidding. No. She was diagnosed in 88 with muscular dystrophy. And she passed away when she was 45, so 3 years ago.
I'm sorry.
But she bit me.
She's forever with you. On your arm. On your arm.
All right. Yeah, I wasn't the asymptote. She didn't know the rules of asymptotes at the time. All right. How will our generalizations change if we have this? Well, we know that we will shift right if we have a negative h and shift left if we have a positive h. And that's part of our exponent. Our asymptote is still the same. And our domain and range are still the same. Ooh, there's something down here further. Oh. Okay. So that allows the right-left shift. If we have this, our point is going to be 0, comma k. Our asymptote is going to be y equals k.
It looks like you.
Hang on. K plus 1. That should be a k plus 1. And then our domain and range. Domain's still negative to positive infinity. The range is going to change to k to infinity. Doing okay? Do I have any more slides left?
Yes.
How many?
1, 2,
One page or one slide?
3.
Two.
Slides.
All right, gonna move on.
Yes.
Okay, find the equation. Yay! Okay, first thing, I don't really know what that point is right there, but I do know what that point is. So this appears that it shifted to the right. Agreed?
Yes.
So I would say this has got to be the equation. Y is equal to, that's 0.5 there. Let's go with a to the bx. Okay, so I'm going to say that my x value, I'm going to shift it to the right. So I'm going to say this has got to be an equation. All right. Let's fill this in. Shift right 1. So things I know, I'm going to have this minus 1. My k value, it didn't shift up or down, so that's going to be plus 0. My a value. So now I have to kind of figure out my a and my b value. So if I plug 1 in, that becomes b to the 0. So if I plug 1 in, I get 1 out. Okay, so this has got to be y equals 1 times b, which has got to be 2 raised to the x minus 1. And there's my equation. So y equals 2 to the x minus 1. This one flips upside down. Yes? So I know I have the negative a. Okay? And go from there. So you know what? Let's hold off on these if they are on the homework. And the homework will be due on Monday. Okay? This is the last slide, I think, right? Okay, the y-intercept. Y-intercept is 0, comma what? What's 7 to the 0?
0.
No, 7 to the 0 is 1. 1 plus 3 is 4. Okay, and the asymptote. My asymptote on this one is going to be y equals 3. This one, my asymptote's y equals 0. 0. If I plug 0 in, that's 4 squared, 16. 16 times 6. Crap, why did you give me that? 6. All right, so does everyone know what the homework will be?
Yeah.
Worksheet 9A, is that right? Worksheet 9A due Monday. And then quiz tomorrow.
No, that always happens. It's like,
Don't be like the cool kids and skip tomorrow as it's the only period.
It's not worth it.
It's not worth it. Guys, girls, take care of one another. See you soon.